All right, welcome back into this section on schema creation. I know all you programmers out there have just been itching to get your hands on the keyboard, and trust me, so have I. But it's been important up to this point that we do spend some time with our theory and terminology. So now, given that that's behind us, it's time to start creating and looking at some code, and that's exactly what we're going to do in the next two sections. In fact, what we're going to do in these three lectures is create our example schema, and then we'll do a detailed analysis of the log of that creation and try to get a better understanding of each of those SQL commands that were used in the creation of this database, or of this schema rather. Sounds good. Before we do that, however, we need to first pause this video and download the resource material entitled it's tough to say, my_store.txt. Go ahead and download that guy now. All right, I'm assuming you've been able to successfully download my_store.txt. Next, I'd like you to take that guy and move it to your root C directory. So you should have C:/my_store.txt. Once you've got that completed, go ahead and rename that guy from a .txt to .sql. For some reason, Udemy does not allow me to upload a .sql extension file, so I had to upload it as a .txt. And now, once you've got it on your hard drive, go ahead and rename that guy to a .sql extension. Very good. All right, next step. Launch SQL Plus. Remember, we downloaded this guy earlier? Well, now's the time to fire him up and get him started. Log in with the username system, all caps, and whatever password you created for your system account. Go ahead, get this all caught up. All right, once you're logged in as system, I want you to type the following: set space echo space on semicolon. Set echo on. Excuse me. That is going to echo all the commands in our script back to the screen. Next, once you've completed that, I want you to type spool space temp.txt semicolon return. What that's going to do is take all the commands off the screen, screen scrape those into a file called temp.txt, and that's the file we're going to analyze after the running of this script to take a look at all the commands therein. Perfect idea. Okay, we're now ready to run our script. @my_store.sql, no semicolon this time, and return. Good thing to remember there. Standard SQL commands do take a semicolon. When you're running a script, you do not. So as soon as you hit return, this thing's going to run very quickly on most computers. On mine, it was probably done in 10-15 seconds. Once it's completed, just go ahead and exit out. We have at this point completed our script, and we have a log of everything that has happened. Excellent, because that log is what we're going to analyze and learn from with respect to commands used to create a schema. Cool. Let's take a look. One more thing, though, before we move on, and that's with respect to SQL Plus, Oracle's command line executable. This tool's got to be 15, 20 years old. I remember using it when I still had dark hair or still had some hair. It's kind of an anchor anymore. The reason we are using it is strictly from a historic look at it perspective. From here on out, we're going to use the more modern SQL developer tool. But I did want to introduce the SQL Plus tool to you just for historic sake and let you know that it's out there. So we've done that now, and we'll let it go from here on out. All right, but one more thing. Sorry, gang, but we've got some housekeeping yet to do. And those of you taking this course for the certification exam, this kind of silliness is on there. So I got to feed it to you, despite the fact that in real life, you never use this stuff. SQL and the commands we're about to look at can be categorized really into 5 subtypes. First and foremost are queries. The keyword select. It's why we all are here and going to play the game, but it goes a little beyond that. In addition to queries, there are data manipulation language or DML statements. Insert, update, delete. Next, data definition language statements, DDLs. These are the ones you use to create a table, alter a table, create an index. All that sort of stuff is going to be considered DDL. We're creating or we're defining elements to the schema. Fourth subset of SQL commands are the transaction control commands. Commit, rollback, save point. We'll get into it in detail as to exactly what these are, but trust me, they're out there. And finally are the data control language statements, the DCL statements, grant, revoke. These have to do with giving users privileges to access various components of your schema. All cool, important probably only if you are taking the certification exams, but if you are, it's real because it's going to be on there just as sure as shooting. So remember, queries, DML, data manipulation language, DDL, data definition language, DCL, control languages, and TC. No, I'm sorry, I messed it up. TC, transaction control, and DCL, data control. Those last two, transaction control, refer to the keywords commit, rollback, and save point, and data control language refer to the keywords grant and revoke. Okay, enough of that. Let's look at our log. Start learning something really important, okay? All right, first thing I want you to do is go out there and find our temp.txt spool file. The Oracle executable, SQL Plus in particular, does not have administrator rights to the root C directory. Let me clue you in, you're probably going to find it in the Oracle let me clue you in, you're probably going to find it here in the Oracle executable bin, right alongside our SQL Plus executable. Anyway, let's copy that temp.txt file somewhere a little more reasonable so we can work with it. I'm just going to put mine here on the desktop for now and open it using WordPad so I can do some highlighting as we discuss going forward. All right, open that bad boy up, and right here at the top of our script, it looks like we had some file level comments, standard documentation processes, right? Backslash, asterisk, comment, and then a closing asterisk backslash. Pretty standard syntax, nothing surprising here at all. Equally common is the use of these little blocked in areas for file level or particularly long comment sections. I suggest you get in the habit of doing the same thing. All right, we drop down our script a little bit and we see a drop user command. More specifically, drop user my store cascade. Pretty obvious what this guy does, right? If the my store user existed, then that user would have been dropped by this command. But what you ask is the cascade keyword. It's pretty simple. If the my store user schema had contained objects, then the cascade keyword would have dropped all those before dropping the user. But again, you might ask, why'd you run that command anyway if you knew the user didn't exist? Well, it's just standard practice to precede any new create user statement with a drop user statement on the same user to ensure we get no issues. It's simple. Many times these scripts fail for one reason or another and you have to rerun them a half dozen times. This statement clears out all that old mess before starting anew each time. Just good practice, and I always recommend doing it. All right, cool beans. That's our first data definition level language command, drop user. Oh, by the way, did you notice our SQL statement ended with a semicolon? Got to remember that. Okay, our next DDL command, we create our new user. In this case, our user or schema is going to be named my underscore. Why did I put that underscore in there? My underscore store, and we'll have a password of my store password. That's what the identified by syntax is specifying. That is, I'm creating a user, my store, with a password of my store password. And I'm just going to forget those underscore in there going forward when I'm trying to speak this because it's tying my tongue. Remember from our earlier terminology that this is really what we use to create a schema owner. And that schema, DB, database, and user are all pretty much interchangeable when it comes to database designers. I, for example, have used the term DB my entire life. Schema is just foreign to me. Oddly enough, Oracle does support a distinct create schema command, which can be used to create distinct schemas within a single user. I've never used it. I've never seen anybody else use it. It's out there because of the ANSI standard and they want to be compliant. Nobody does it that way. Just let a user own all your schema objects, and if you need a second schema, create an additional second user. Note, however, this guy's being run, this create users command is being run by system or the sys user under the system or sys user account. We never, ever, ever create new schema objects in the sys or system user accounts. These guys own all the metatables, tables that store information about the real schema objects and the real users. Trust me, that's plenty of responsibility for these accounts. Let's not create confusion by adding real objects to their ownership. I have gone in and consulting jobs and seen such a mess under the system user account. Please don't do that. All right, the next command is a commit. Any idea as to what this does? Sure. It's our first transaction control language command, and it's telling the database to go ahead and physically realize that last set of commands. Just as a look ahead at this point, the correlates to commit are rollback, which sort of says to the database, hey, I think I've made a terrible mistake. Let's back everything up to the last commit or save point or rollback. And save points are just what they sound like, and they're pretty much like breakpoints in your standard program debugger. It basically says, here's a point at which I may want to commit from or roll back to. Basic stuff. Okay, next command requires a little explanation because here the command option become pretty tricky. Grant connect, resource to my store. Okay, what's going on? We're assigning privileges to the my store user. In this case, more specifically, the ability to connect to the schema and then create objects or resources within that schema. All right, cool, that sounds reasonable. But what are my other options with respect to the grant statement? Well, the short answer is there's probably thousands of them. They just are a ton of variants on the grant theme. Let's take a look at a couple examples so you get an idea. Here's a real common one. I am now in Developer and logged into our Oracle account as system. I want to grant the DBA role to the My Store user. Roles can be predefined by Oracle, such as this one, DBA or Database Administrator, or created specifically by the properly privileged user. The DBA role is a very common one, used predefined role, and basically provides the owner with the rights to create additional users who can then be given various access rights to the schema. The with admin option of this statement allows the owner to turn around and create additional DBA role users. That is, when I grant a role with admin options, the person who or entity that received that role can turn around and grant it to others. All right. Let me log in here as the MyStore user who now has these DBA privs. Let's go ahead and create another user named External Programmer and grant that user standard select, update, or insert and delete privs to the customers table. Very standard practice for allowing external programmers a common method for connecting to the DB. What about a user-defined role? Here's an example where we create an HR clerk role and then grant that role access to the employees table, so they can do their work on it. Finally, we create a new specific user, HR clerk Sam, and grant him the HR role. Just a different method for realizing the exact same objective, getting someone access to the database, but just the access they absolutely need and require and nothing more. That's the name of the game. DBAs make a very nice living and spend a lot of their time doing exactly this, figuring it out and perfecting it. Finally, before we move on, what happens if Sam transfers to the receiving department and is no longer serving as an HR clerk? Well, we revoke, keyword revoke, his HR clerk role, of course. Okay, what happens next? Through sheer luck, Sam turns around and wins the lottery and never shows up for work again. What do? We drop the HR clerk Sam user altogether. Yes, keyword drop. Good luck in the future endeavors, Sam. See you around, buddy. Alrighty, that's probably a pretty good place for us to break on this lecture before we move on analyzing our create schema log in the next lecture. What did we learn? We learned about SQL Plus, Oracle's command line tool, and we took a look at it really for historical purposes because it's been replaced now by the Oracle SQL developer tool, which has got a much nicer user interface and a much more sophisticated tool set. All right, we also addressed SQL subtypes, particularly for those of you who are going to go on and get certified, take those Oracle exams. You need to know this. We then started analyzing our log of our actual create schema script. Right at the top, we saw a drop user cascade command. Very standard practice to ensure that everything gets cleared out prior to our actually creating a new user. After our drop user, we did a create user, username identified by password. Standard syntax. Remember, these guys need to end with a semicolon. Next, we granted some access privileges, in particular connect and resource, to our new users such that they could get on their new schema and start using it. Also, with a brief discussion, don't forget we had a brief discussion of how to comment your scripts, real standard, backslash, asterisk, comment, asterisk, backslash, and you're golden. Cool beans. That pretty much wraps it up for this lecture. We'll see you in the next one when we actually connect as the MyStore user and start creating objects within that schema, within that account. All right, we'll see you in the next lecture. Go out there and have some fun. In the interim, remember to learn something today.